Hello guys, I welcome you all to my channel, and today we are going to discuss a very important topic of the thermodynamics, which is work transfer. This work transfer is highly important. So आज का जो हमारा ये लेक्चर है वो थोड़ा लंबा होने वाला है, and at the same time you have to build up the concepts because this is the fundamental. Here we will come across the several processes, how to calculate the work transfer for the closed system. Here we will talk exclusively for the closed system only. Okay, for the flow system, for the open system we will talk later on, but now on our focus is on the work transfer for the closed system only. Okay, so what is the work transfer? The very first question है ना. So हमने मैकेनिक्स में देखा है that work transfer is the action of force causing displacement. So force multiplied by displacement is known as work in mechanics. Okay, so in mechanics term this was the definition and this is the definition. But in the thermodynamics, work is said to be done by the system. Okay, this by the system is important here. Okay, so work is said to be done by the system if sole effect external to the system. Okay, the sole effect external to the system can be reduced in the form of lifting weight. Okay, I know that this sentence seems to be a little tougher, but let's make it easy. Okay, तो हम कब कहेंगे कि सिस्टम ने वर्क किया है? सिस्टम के द्वारा, है ना, वी विल सेड कि सिस्टम के द्वारा वर्क किया गया. अगर जो सोल इफेक्ट है, जो हमारा सिस्टम का जो सोल इफेक्ट है, अगर हम उसको इस फॉर्म में ले आए कि वह जो है वेट को लिफ्ट कर सकता है, वेट को उठा सकता है. अगर हमारा सिस्टम जो है अगर वेट को लिफ्ट कर सकता है, देन वी विल से दैट वर्क इज डन बाय द सिस्टम. आई होप कि अब थोड़ा चीज़ें क्लियर होंगी कि भाई अगर हमारा सिस्टम का इफेक्ट जो है ऐसा है कि वह जो है वर्क वेट को लिफ्ट कर सकता है. इफ द सोल इफेक्ट एक्सटर्नल टू सिस्टम कैन बी रिड्यूस्ड इन द फॉर्म ऑफ लिफ्टिंग वेट, देन वी विल से दैट यस वर्क इज सेड टू बी डन बाय द सिस्टम. आइए अब इसको अच्छे से एग्जाम्पल के साथ हम समझते हैं. जैसे देखिए एक सिस्टम है, ये हो गया हमारा बैटरी. बैटरी से कनेक्टेड है मोटर, और अब यह जो है घूमेगा. ओके, दिस इज द केस. तो इस केस में यहाँ पास तो कोई एक्चुअल वेट नहीं है ना. एक्चुअल वेट नहीं, हमको उस फॉर्म में रिड्यूस करके देखना है, चेक करना है. हमको हर एक केस में चेक करना होता है. वहाँ पास आपको रियल में वेट नहीं मिलेगा, बट यू जस्ट हैव टू चेक दैट वेदर वी कैन रिड्यूस इट इन द फॉर्म ऑफ लिफ्टिंग वेट और नॉट. तो देखिए ये हो गया बैटरी मोटर. अगर हम इस मोटर से कनेक्ट कर दें एक वेट को, और अगर हमने जब बैटरी से कनेक्ट करेंगे देन मोटर रोटेट करेगा, और यस यह जो है हमारा वेट को ऊपर उठा सकता है. देन यस डेफिनेटली हियर वर्क ट्रांसफर इज अकरिंग. ओके, द सेकेंड थिंग, यहाँ पर देखिए ये जो है बैटरी है, और ये जो कनेक्ट है किससे? इलेक्ट्रिकल लैम्प से. अब हम इसको फिर से रिड्यूस करने की कोशिश करेंगे. अब हमने इस लैम्प को हटाकर यहाँ पर डाल दिया मोटर. Now again motor can rotate and it can lift the weight of the system. एक certain weight को यह again lift कर सकता है. In this case also we can say that yes work transfer is occurring, है ना. So in these two cases we see that weight is not really present here, है ना, but we can reduce it in the form of lifting weight. हमने इसको एक उस फॉर्म में रिड्यूस किया जहाँ पर हम वेट को लिफ्ट करके देखते हैं. और अगर हमारा वेट लिफ्ट करने में अगर हमारा सिस्टम जो है ऐसा है कि इट कैन लिफ्ट द वेट, देन वी विल से दैट वर्क इज डन बाय द सिस्टम. नाउ लेट्स टॉक समथिंग वेरी इंपॉर्टेंट. हमने यहाँ पास अपना सिस्टम कंसीडर किया किसे? बैटरी से. वाई? बिकॉज दिस इज अवर बाउंड्री, दिस इज द बाउंड्री ऑफ द सिस्टम एंड दिस ऑल आर सराउंडिंग. सो हमारा सिस्टम हो गया यह बैटरी. तो अब हम यहाँ पास कौन सा वर्क हो रहा है कहेंगे? हम कहेंगे भाई कि बैटरी से इलेक्ट्रिकल वर्क जा रहा है बाहर, जिसके कारण जो है मोटर जो है घूम रहा है ना, एंड देन वेट जो है रेज हो रहा है. सो इन दिस केस वी से दैट इलेक्ट्रिकल वर्क इज अकरिंग. ओके, क्यों? क्योंकि जो हमारा सिस्टम है यह है हमारा बैटरी, और जो सिस्टम जो वर्क है बैटरी वो जो है वहाँ से इस बाउंड्री को क्रॉस कर रहा है, इन दिस केस इलेक्ट्रिकल वर्क। आइए दूसरे सेकंड केस देखते हैं। सेकंड केस में भी हमारा सिस्टम जो है बैटरी है, इन दिस केस ऑल्सो वी आर गेटिंग इलेक्ट्रिकल वर्क, क्योंकि यहाँ से देखिए जो वर्क जा रहा है वह जो है इलेक्ट्रिकल ही जा रहा है। देन बाय via this motor the electrical work is converted into what? Mechanical work, है ना? So here in this case also we will say that electrical work is occurring, here also we say electrical work is occurring. Now let's change the system. अब हमने इस बैटरी प्लस मोटर इसे अगर हमारा सिस्टम माना, ओके अगर हमने इस बैटरी प्लस मोटर इसको अपना सिस्टम माना, तो हमारा सिस्टम से बाहर क्या मिल रहा है हमको ये शाफ्ट जो है रोटेट हो रहा है। देन इन दिस केस वी विल से वी आर गेटिंग व्हाट? मैकेनिकल वर्क। और अगर अब हमने अपना सिस्टम इस शाफ्ट को भी ले लिया, इसको पूरा को अपना एक सिस्टम माना, देन इन दिस केस वी विल से दैट नो वर्क ट्रांसफर इज टेकिंग प्लेस, है ना? तो अब हमने देखा कि it is depending, work transfer is depending upon the type of system what we are choosing. हम जो सिस्टम एज्यूम कर रहे हैं इस पर भी हमारा जो वर्क ट्रांसफ़र है वो डिपेंड करता है कि हम सिस्टम कौन सा चूज़ कर रहे हैं। अगर हम सिर्फ बैटरी को अपना सिस्टम मानते हैं, इन दिस केस वी आर गेटिंग इलेक्ट्रिकल वर्क। इफ़ वी आर एज्यूमिंग बैटरी प्लस मोटर एज अवर सिस्टम, देन वी आर गेटिंग मैकेनिकल वर्क। And if we are choosing battery, motor as well as shaft as our system, then we see there is no any work transfer, है ना? तो इस सारे डिस्कशन से इस केस में हमको वर्क ट्रांसफ़र क्यों नहीं मिल रहा है? क्योंकि ठीक है यहाँ पास मोटर घूम रहा है बट इट इज़ नॉट क्रॉसिंग द बाउंड्री, हमारा जो सिस्टम है। सो यहाँ से हम एक कंक्लूजन निकाल सकते हैं दैट वर्क ट्रांसफ़र इज ए बाउंड्री फिनोमिना। हाईली इम्पॉर्टेंट, very 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 important that work transfer is a boundary phenomena, and the work transfer is only significant when it crosses the boundary. जो वर्क है जब तक वर्क हमारा बाउंड्री क्रॉस नहीं करेगा तब तक हम नहीं कहेंगे कि वर्क ट्रांसफ़र यहाँ हो रहा है। जैसे कि हमने इस केस में देखा, भाई यह बाउंड्री को क्रॉस कर रहा है, देन ओनली इट इज कॉल्ड एज इलेक्ट्रिकल वर्क। यहाँ भी बाउंड्री को क्रॉस कर रहा है, देन ओनली इट इज इलेक्ट्रिकल वर्क। अब ये हमारा जो बाउंड्री है इसको क्रॉस कर रहा है, कौन सा वर्क? मैकेनिकल वर्क, देन ओनली इट इज मैकेनिकल वर्क। बट हियर देयर इज नो एनी वर्क इज क्रॉसिंग द बाउंड्री, दैट इज वाई नो वर्क ट्रांसफर इज हियर, एंड दैट इज वाई द वर्क ट्रांसफर इज व्हाट? ए बाउंड्री फिनोमेना। आई होप कि दिस वर्क ट्रांसफर कॉन्सेप्ट एंड वाई वी called it as a boundary phenomena is very much clear to you. Now the next, now let's talk about the sign convention. It is very much easy. If there is work transfer by the system, then it is positive, and if the work transfer is on the system, then it will be negative. Okay, it is very easy. So by the system means if there is expansion by the system means expansion, so expansion is considered as a positive and compression will be considered as negative. Okay, now let's see the closed system work. Okay, closed system work also known as non-flow work, also known as displacement work, also known as PdV work. So let us consider a piston cylinder arrangement considering some gas, and this is our what? System, and this is our system boundary. Okay, now this piston is moving and displaced by a distance dx. So we know that work is given by force multiplied by displacement. Force we can replace by pressure into area into displacement. So this a dx we can replace it with dv, which is change in volume. Area into change in length will give change in volume. So here we will get a very 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 important formula which is PdV. So the work transfer of the closed system will be given by the formula dW equal to PdV. Remember, this formula is valid under these two conditions, that this formula is applicable for the closed system only. It is not applicable for the open system. You cannot apply this work formula for the turbine, for the compressor, no. This you can apply for the closed system only, number one. So you must check that whether your system is closed or open. And the second one, you can apply this formula for the reversible process. You cannot apply this formula for the irreversible process. Okay, so these two criteria you must remember, that where to apply this PDV work formula. Now this PDV, if we talk about this formula in the graphical ways, then the work we can calculate the work, or specifically called closed work, by considering the area under this curve. Okay, if we project this graph on the volume axis and then consider the area under this curve, then it will give us what? Total work. Okay, so W1 to 2 work transfer from 1 to 2 state will be given as integration of V1 to V2 PDV, or it is the area under this curve. The area under this curve will give the total work or work transfer from this point 1 to 2. Now there is one interesting thing and very important thing. If you think it theoretically, then it is very important, and it has been asked so many times in the SE examination also. So you see that this is 1, this is 2, and we have just seen that area under the curve give work transfer. Okay, so here you see this is a process, and here this is the process. Since the states are the same, the point 1 and 2 is same, but the path is different. So if the path is different, for this process let it be 1, so for the process 1 this area gives work for the process 1, but for the process B, this is the total work. So clearly we can see that yes, the state points are same, the initial and final states are the same, but it depends on the path. If we go by path A, we will have this much work, and if we go with path B, we will get this much work. So that is why work transfer is a path function. We have seen that each and every property is a point function. There we have seen that properties are the point function which depends upon the state only, point only, which doesn't depend upon the path. But here the work transfer is a property which the work transfer is a path function which depends upon process or path. That is why it is known as path function. Okay, so we have seen two important conclusion about this work transfer. Number one, work transfer is what? Work transfer is a path function. Number first, work transfer is a path function. Important conclusion. And number two, the work transfer is what? Boundary phenomena. That it depends whether the work is crossing boundary or not. Okay, so this is theoretically very important for the work transfer. Work transfer is a path function and work transfer is a boundary function. These two concepts are highly important if you talk for the ESE. Now let's see different processes and different formula for the work transfer. So the first process is constant volume process. Constant volume process को ही क्या बोलते हैं? Isochoric process. Okay, in this process volume is constant, that is why constant volume process. Now for ideal gas we know that PV equal to mRT. If volume is constant, it means pressure is directly proportional to temperature. अब भाई PV डायग्राम में आप देखें तो this is P, this is V, and now अगर हमारा initial 1 to 2, if this is our process, constant volume means volume is constant, same volume throughout the process, and if this is our first process, this is second, means pressure अगर हमारा बढ़ रहा है, प्रेशर अगर हमारा बढ़ रहा है, इट मीन्स टेम्परेचर भी बढ़ेगा. दैट इज वाई दिस प्रोसेस 1 to 2 इज व्हाट? कांस्टेंट वॉल्यूम हीट एडिशन प्रोसेस. हीट ऐड करेंगे तभी तो टेम्परेचर बढ़ेगा. एंड जस्ट रिवर्स, इफ दिस इज अवर इनिशियल स्टेट एंड दिस इज अवर फाइनल स्टेट एंड दिस इज द प्रोसेस 1 to 2, देन इट दिस केस प्रेशर इज डिक्रीजिंग. प्रेशर भाई कम हो रहा है. प्रेशर कम हो रहा है मतलब टेम्परेचर भी कम हो रहा है, दैट इज वाई दिस इज कांस्टेंट वॉल्यूम हीट रिजेक्शन प्रोसेस। ओके, नाउ लेट्स सी व्हाट इज द वर्क। जैसा हम लोगों ने अभी बात किया कि भाई एरिया अंडर द कर्व विल गिव, एरिया अंडर द कर्व ऑफ दिस पीवी डायग्राम विल गिव वर्क ट्रांसफर। देन दिस एरिया, व्हाट इज द एरिया? नो एरिया, there is no area under this curve, the area will 0, so work transfer will be 0. Or you see volume is equal to constant, it means change in volume, the differentiation of any constant term is what? 0, so dv is equal to 0 here. Then this work transfer integration of p dv will be also 0. So now here you see constant volume means a rigid container. Volume will be constant when all the boundaries will be what? Rigid. ये हमने पहले भी देखा हुआ है। और यहाँ से आप जो है हीट इन कर सकते हैं या फिर हीट आउट कर सकते हैं। सो कांस्टेंट वॉल्यूम हीट एडिशन, कांस्टेंट वॉल्यूम हीट रिजेक्शन, दिस इज द बेसिक structure of the constant volume process in which the work transfer is 0, and this is the PV diagram for the constant volume process. Okay, now the second process is constant pressure process, also known as what? Isobaric. Isobaric process or constant pressure process in which pressure is kept constant. Now let's see the PV diagram. Here the pressure will be constant, so it will be what? Horizontal, means constant pressure throughout the process. Now if this is our 1 point, this is 2, and if it is going like this way, it means volume is increasing. Okay, and here pressure is constant, means volume is directly proportional to temperature. If we are increasing the volume, means temperature is also increasing, hence this process volume is increasing and temperature is increasing. So this can be defined as constant pressure heat addition or constant pressure expansion process, है ना। अब वैसे ही हम इसकी बात करें तो यहाँ पर हमारा जो वॉल्यूम है वो कम हो रहा है। वॉल्यूम अगर कम हो रहा है मीन्स टेम्परेचर कम हो रहा है, और टेम्परेचर कम हो रहा है मतलब कि हीट रिजेक्शन हो रहा है। सो इन दिस, और यहाँ पर साथ ही साथ में कॉम्प्रेशन भी बोल सकते हैं, क्यों? क्योंकि वॉल्यूम जो है कम हो रहा है। दैट इज़ वाई दिस प्रोसेस वी विल termed it as constant pressure heat rejection or constant pressure compression process. Okay, now as we know that work transfer is integration of p dv, and here the pressure is constant, that is why this is the formula for the net work transfer. आई होप कि यहाँ तक तो चीज़ें क्लियर होंगी। या फिर एरिया अंडर दिस कर्व, आप सीधा रेक्टेंगल प्रेशर इनटू दिस वॉल्यूम, दिस एरिया का जो रेक्टेंगल इट विल गिव यू व्हाट? नेटवर्क ट्रांसफर। अब आइए हम इसका अरेंजमेंट देख लेते हैं, दैट हाउ द कांस्टेंट प्रेशर अरेंजमेंट होगा। तो अगर हमारा एक पिस्टन है और इसके ऊपर एक वेट है W, व्हेन वी सप्लाई द हीट ऑन दिस गैस, देन व्हाट हैपन ना कि ये जो पिस्टन है इट विल गोज अपवर्ड। क्यों? क्योंकि भाई अब यहाँ का जो प्रेशर है वो बढ़ रहा है, and it will maintain its pressure in equilibrium with this P atmospheric and weight pressure, क्योंकि यहाँ से हमको बाहर से कितना आ रहा है? एटमॉस्फेरिक प्रेशर एंड प्रेशर ड्यू टू दिस वेट, है ना। इधर से बाहर इतना ही प्रेशर, तो अगर यहाँ पर प्रेशर बढ़े एवरी टाइम इट ट्राइज टू गो ऑन द इक्विलिब्रियम विद दिस प्रेशर, so each and every state it will be in equilibrium and it will be under the same pressure what this atmospheric pressure and this weight pressure combinedly together occurs, है ना। So at each state the pressure will be same in equal to P atmospheric and pressure plus pressure due to this weight. So this is the example of what? Constant pressure process, where we can add heat or where we can reject heat also, है ना। So this is the arrangement for this constant pressure process. Now the third process we would like to discuss here is isothermal process. Isothermal process means what? Temperature equal to constant. Now so that if temperature is constant, then we will have PV equal to constant, and this PV equal to constant seems so much equal to what? XY equal to constant, which is the formula for what? Rectangular hyperbola. So this question has been asked in some examination that the isothermal process, okay, that this graph of the isothermal process in the PV diagram is follow which equation? So it follows the equation of rectangular hyperbola, that xy equal to constant. So this is a rectangular hyperbola. The curve is rectangular hyperbola for the isothermal process. Okay, so now if the this, as we can see that, yeah, volume is increasing, that is why this is isothermal expansion. Here volume is decreasing, that is why isothermal compression. Okay, and now let's see what is the work transfer. W1 to 2 is given by integration of PdV. From here we can write P equal to C by V and substitute here C by V dV. Take this C outside, you will have dV by V integration. We know that dV by V is ln V. So by this PV ln V2 by V1. Now PV is equal to constant, which means we can write P1 V1 equal to P2 V2. So from here we can substitute V2 by V1 as P1 by P2. So this is the ultimate formula, and this is the formula you have to remember, that the work for the isothermal process is PV ln V2 by V1 or PV ln P1 by P2. Okay, so all those EAC candidate which wants to crack the EAC examination, this is one more point you have to remember, that isothermal process is very slow process. So this is in, I don't know the exact year, but this is the previous year question of the EAC. Yes, isothermal process is very slow process. This thing you also have to remember. So now the next process is polytropic process. Now polytropic process, the equation of the ideal gas equation for polytropic process is PV to the power n equal to constant, and n value varies from the 1, not equal side here, n value varies from 1 to gamma in between. Okay, and n is what? Polytropic index. Like we know that PV equal to constant is what? Isothermal process. Likewise the polytropic process follows this PV to the power n equal to constant, with where n is polytropic process and n lies between 1 to gamma. So we can write P1 V1 to the power n equal to P2 V to the power n equal to constant by this. Let's calculate the work transfer. Integration of PdV, instead of P we can write C by V to the power n. Here taking C out, integrating V to the power minus n dV, we will get this formula. Substitute C here as P2 V to the power n, and here P1 to the power V1 to the power n, and finally we will get this equation, which is highly important, that the work for polytropic process will be given by P1 V1 minus P2 V2 by n minus 1. Okay, and remember that this polytropic process lies between 1 to gamma. This is also very important. Okay, now in this case, in polytropic process there is both work transfer as well as heat transfer. Okay, so both energy transfer take place in the polytropic process. Now likewise the polytropic process, there is another process which is adiabatic process, which ideal gas equation is given by PV to the power gamma equal to constant. Now similarly we can derive the formula for the work like the polytropic process, and the work transfer comes out to be P1 V1 minus P2 V2 by gamma minus 1. Okay, now the thing which you have to remember here is that this adiabatic process is the very fast process. Okay, so the adiabatic process is very fast process, while the isothermal process is very slow process. This is what the previous year examination or question. This is the previous year question, that isothermal process is very slow process and the adiabatic process is very fast process, because you see here all walls are very well insulated, that no any heat transfer take place, as the name itself suggests that this is adiabatic process, so no heat transfer, so all walls are very well insulated. Now suddenly you have to release this stop, so that this piston will, within a fraction of second, it will goes to here. At this moment, no any heat transfer will take place, because for the heat transfer to occur, it needs some time, but here the time is very less, because it is very fast process, and that is why there will be no any heat transfer, and it is the process of adiabatic process. Okay, so I think जो ये हमने अभी तक प्रोसेस पढ़ा और इनका जो वर्क ट्रांसफ़र पढ़ा, आई थिंक कि ये आपको अभी समझ में आ गया होगा. नाउ नेक्स्ट थिंग, लेट्स स्टडी दैट हाउ टू रिप्रेजेंट द वेरियस प्रोसेस इन पीवी डायग्राम. हाउ टू represent various process in PV diagrams. Okay, so all the process can be represented in PV diagram, and all the process can be given as equation like PV to the power k equal to constant. So in this case, by varying this value of k, we can get all the processes which we have discussed earlier. Okay, let's see. So if our k value is 0, है ना, if this k value will be 0, which means v to the power 0 is 1, it means pressure is equal to what? Constant. So this pressure equal to constant line and k equal to 0 line, or this k equal to 0 line. Okay, now so it will be what? Isobaric process if k equal to 0. Now if k equal to 1, then it will be PV to the power constant, and it will be isothermal process. So this is k equal to 1, or this is k equal to 1. Likewise, now k equal to gamma, it will be PV to the power gamma equal to constant, which will be what? Adiabatic process. So this is the k equal to gamma, this equal to k equal to gamma, and we know very well that the polytropic process lies between, k value will be what? 1 to gamma. So it will be lie between this 1 to gamma. So this will be polytropic process. Now if k value is infinite, it means volume is constant. So k equal to infinity, volume is constant. So by this changing the value of k, we can express all the process in the PV diagram. Okay, now let's talk about slope. That what do you mean by the slope? So slope can be defined as tan theta, and if we cannot define it in by angle, then it will be defined as dy by dx. So the very first process is pressure equal to constant. So this is the line. Here we can say we can see that theta equal to 0. So if theta equal to 0, then slope will be what? Tan 0. It means 0. So the slope on the, so 0 slope on this PV diagram is what? Isobaric process. Okay, tan 0 0. So this isobaric process will have 0 slope on the PV diagram. The second one is temperature equal to constant. So slope we see PV equal to constant. This is the isothermal line. Here we can see that we cannot conclude on this angle term, so we will simply differentiate it. If we differentiate it, we have P first function ddx of second function dd of second, and this constant term will be 0. So here we will have dp by dv, which means dy by dx. Here y is p and x is v, so dp by dv is equal to minus p by v. So this is the slope for the isothermal. Now next is adiabatic. Here also you have to differentiate first function. This differentiation will be nx n minus 1, and this, then second function ddx of n, and then from here also we will get dp by dv as gamma into minus p by v. So from here we can conclude one thing, that the slope of the adiabatic process is higher than the slope of the isothermal process, and also the slope of adiabatic is gamma times the slope of isothermal. So here you see note point that the slope of adiabatic is greater than slope of isothermal, and the slope of adiabatic is gamma times slope of isothermal. Okay, now the next one is volume equal to constant. So here the theta is 90 degree, so we can easily calculate the slope as tan 90, and tan 90 will be what? Infinity. So infinity slope on the PV diagram is a what? Constant volume or isochoric process. We have covered this two note point also. Now let's see some more note points. Some more note points is like the area under the PV diagram. Suppose if there is cycle, this, and this is PV. So this area under this PV diagram, na, area of this cycle on this PV diagram will give you what? Net work transfer. Net work transfer. It will give net work produced by this cycle. Okay. And now the two also very important thing which is sometimes asked in the examination. Any cycle which rotates clockwise, any cycle which rotates clockwise will give you what? Positive work. And any cycle which rotates anti-clockwise, it will what? Power consuming cycle. We have to give work to this cycle. Okay, so two important points from here, that all the power producing cycle like Otto cycle, diesel cycle, whatever you see, all the power producing cycle will be what? Clockwise type. While all the power consuming cycle, all the refrigeration cycle, those will be what? Anti-clockwise cycle. So I hope guys you like this lecture of today. I know that this lecture was quite lengthy, but at the same time it was highly important. In the next class we will cover some important questions and also the heat transfer. So guys, take care, stay healthy, stay safe, and if you are not subscribed my channel, then make sure that you must subscribe my channel. Okay, thank you, bye bye.